Welcome to a tutorial video on C++. In this video, I'm going to talk about variables and data types. Variables are a way to contain data in programming terminology. We often think of variables as a type of bucket. That is, we put values into the bucket and then we can examine the bucket to see what values are inside of those. Because C++ is a system-level programming language, that is, it deals with low-level stuff, the types of data are very important when considering these buckets, what values we're putting in. C++ is a strongly typed programming language, so we have to care about what data is put into these buckets, what values we're putting into variables. Let's look at some examples here. Starting over here on line 6, we see int, which is a key word that describes a type of data. After that is the name of a variable, number value in this case. In C++, variables can contain letters, numbers, and the underscore. They cannot contain spaces or other special characters. So we see here the example of a variable. And before that, int, which I started to talk about, is a type of data. I mentioned that C++ is a strongly typed programming language. This is important because, like I said, we have to care about what data we're putting into these variables. In this case, it is an integer, or sometimes called a whole number. That is, it doesn't have a decimal part. We see that over here on the other side of the equal sign. On the right-hand side is a whole number, 5. 5 in this statement right here on line 6 is being put into the variable number value. The type of data over here is an int, or an integer. So we're putting data into this variable. We see right here in the middle is the equal sign. This says that this is an assignment operator, that is, we're assigning some value. We're putting value into the bucket that is the variable. So, looking at this line as an example of lines we're going to talk about throughout this video, we see the type of data at the beginning, the name of the variable, the operation, in this case assignment, we're putting data into a variable, putting data into this bucket, and then the data we want to deal with. In this case, a whole number because it is an integer. Let's move on. Talking at line 9 now, we see a similar pattern that I just described. The type of data, float in this case, the variable name, the assignment operator, we're assigning, we're putting data into, and then the data we're dealing with, in this case a decimal. The keyword float is an abbreviation of a longer phrase of floating point, meaning a decimal value. In programming terminology, a floating point variable or floating point data is something that has a decimal value. That is, the point floats. It's an easy way to think about that. So this is a float or a floating point or a decimal value. So we have a decimal value, 4.5. We're putting into, notice the assignment operator, this variable right here. Now, as we move on to some of these other types, I want to take a second to talk about C++ in a more generalized way. Because it is a system-level programming language, it cares about the space variables take up. The bigger the value, the more space it takes up in memory. Because C++ came about in an earlier time when memory was very, very important, it cares about how much space you're putting values into. So we see earlier with integers and floats that they grow a little bit bigger. The float, the amount of space a float or floating point decimal value takes up is bigger than the amount of an integer it takes up. As we move into these larger and larger sizes, they take up more and more and more space. However, they also allow us to do calculations on much larger or much smaller scales, which is also important due to the scientific nature that programming language can be used in. You want to be able to calculate, for example, say, stars in the sky, as well as microscopic entities. So scale is important as well as size is important. And C++, as I said, arose during a time when these were very important information when dealing with these values. We wanted to know how much space is this taking up? Do we really need to use this, or can we use something else to do these calculations? So we've talked about integers and we've talked about floats. Let's talk about doubles. So a double is a larger or a smaller value than an integer. That is, if we want to deal something that's bigger than, say, 65,000, we might use a double. And so we see here a very large number. Not the largest number, but a larger number than integers. So a double you can think of, although this isn't quite correct, you can think of as sort of double an integer size. So a larger number. A long, right here with the keyword long, is a larger number than a double. So we can think of integers and floats as sort of whole numbers or decimals. We have a double, which is double the size, a long, which is even bigger than that, and then down here we have a long double, which is even bigger than that. So a largest or smallest number. Again, thinking of the metaphor and the way of thinking of either thinking about stars or thinking about microscopic entities. We care about the size of the data, how much space it's taking up, but we also want to do calculations on very large or very small numbers. So we can build in size from integers or floats, whole numbers or decimals, move over to doubles as bigger than that, long as bigger than that, and long double as even bigger than that. Finally, we have two more very common types of data: characters and booleans. A character is a single letter, number, or special character, including spaces and everything else. It is a single one of those. It is a single character. It's represented by single quotes around something, in this case A. And the type of data is char, or character. So we see here, as the pattern we've talked about here, we have the type of data, the variable, the operation, and then the data we're working with here. So we are assigning, putting in a single character, into the variable letter value, which represents this A. The type of data is a char or character. Finally, we have Boolean values. Boolean values are either true or false. That's it. They only have two possible values. And as I'll get into in later videos, these are important when dealing with conditional statements and other more complex data structures and programming flow operations. Here, though, we see the similar thing we've seen throughout this. We see the type of data, a bool for a Boolean, so either true or false, the name of the variable, true or false value in this case, and remember, as a review, variables can have letters, numbers, or the underscores, but no spaces or other special characters. The operation we're doing, assignment, putting data into the bucket, putting a value into the variable, and its value, in this case, true. And remember, a Boolean can either be true or it can be false. So let's review all of this. We're talking about variables and we're talking about data. C++, as I mentioned at the beginning of this video, is a system level, sometimes called a low-level programming language. It cares about the size of data and it needs to know what type of data you're working with. So it is a strongly typed programming language. We really need to know what type of data because we need to know how much size that data is going to take up internally. There are a number of different types of data as we've talked about. We have integers using the key word int. These are whole numbers. We have floating point numbers or decimal values. Then we have a double, which is a larger number than a float or an integer. We have a long, which is a larger number than that. And we have a long double. Notice both keywords being used, which is even bigger than that, the largest or the smallest numbers. And we talked about here, we can either use those to look at the stars or look at microscopic entities, but we care about the size of this data as well as its type, because its type dictates size. And because this programming language arose in a time when memory was very important, those values were baked in this language, and so we need to know the type because we need to know the size. Is it important that we really use a long double if we're only dealing with like 0.0 or 0.2? Maybe not, and a float would probably be better. Finally, we closed off with two other data types. A character, which is a single letter, number, special character, or underscore in single quotes. A character, and we ended with Booleans with the keyword bool, which are either true or false values. Thanks for watching.